Cool. Well, thanks for everyone for sticking around this late on a Monday night. I know I'm the last one, so yeah, really appreciate that. Just a quick question, because this is going to be a talk a lot about React Native. How many people here have used or do use React Native? Oh, cool, that's a good number. And how many of those who had their hands up like Indiana Jones or Monty Python? Okay, I'm really sorry for the rest of you guys. So I'll give a quick background to me, who I am, the company I work for, and it'll kind of hopefully play into that stuff. So I work for a company called Anaplan. This is my stealth t-shirt. And Anaplan isn't a company that a lot of people will know because they only sell to other businesses, but they make cloud planning software. And what is cloud planning software? Well, imagine a company like, let's say Coca-Cola, and they want to know how many bottles they're going to need next month in every country around the world. And then they want to know all the data that's going to be around that. So what's the weather going to be like in all these various countries? What did they sell last year? What are they thinking they're going to sell this year? And then they want to tie that in with how much revenue they're going to make from those, how much are they going to pay in commission to their traveling sales guys. And you suddenly realize that actually knowing how many bottles they want to make is only part of planning their business. It's this massive web of connected information that they really want to bring together. And that's what Anaplan allows you to do, rather than a bunch of Excel spreadsheets that people are going to overwrite and leave in a Dropbox and lose and find again and whatnot. So that's what Anaplan does. We use a variety of different technologies on the back end and the front end. But of course, this is a React talk. We do use React. We use React quite a lot in our web front end, and it is a cloud platform, so web is our primary front end. But about a month and a half ago, we released our first mobile app on the App Store, and we are using React Native completely for that, which is really cool. So the talk here is about the hunt for the Scrolly Grail and grids in React Native. And the first thing I'd like to define is, what's a grid? Well, I'm using the term grid here, but it is a table or a worksheet in Excel or whatever you want to call it, some form of laying out data in columns and rows. And this is something that's hopefully familiar to a lot of people. This is an example of a grid in Anaplan. And I'm going to make some assumptions about grids in general before I go any further into this talk. And that is that at some point, I'm going to want to show a lot of data. So the specific use case that we had at Anaplan is that there is potentially a hell of a lot of data that a company that is the size of, again, Coca-Cola or HP or Cisco, that they want to be able to consume and work out and pivot around. And we want to comprehend that as humans. And this leads into the second point, which is I'm going to assert that humans think in rows rather than columns. Now, I'm doing this partly because it suits my use case, but I think it's something that's broadly true. We prefer to scroll down information on a web page rather than try and scroll across. And the last thing I want to say is, well, this is a React Native talk. We're a bunch of React developers. We like JavaScript. So we want to try and keep this solution in JavaScript, not Java or Objective-C or Swift. So hopefully that will keep it relevant to everyone in the room. So I'm also going to talk about the shape of the data. And again, I've made this convenient for myself for the purposes of what we're doing. But this is broadly true of the actual project and the data that we're getting in there. So you can see here that a piece of JSON which vaguely represents my grid of data that I want to represent. So we have a grid, which is an array. We've got rows of data which have their own ID for convenience in React and keys and things. And each of those has an array of cells, and cells themselves, again, have some kind of ID and a value that we want to display. So nothing complicated here, no rocket science. And if I was to show you a basic grid in React Native, it would look something like this. So for those who haven't done React Native before, imagine that view says div, and you're basically there. It uses Flexbox as its default layout. So in here, I'm saying I want to have a grid, which is my outside view, and I want to, in that, map over some data and lay them out in rows, and each of those rows, again, is going to have a cell, which will render out another little div, which is going to be my value in there, and we can see the pictographic example of that. And, that's great for just rendering a static grid, but what happens when, my grid gets quite big. Again, we're talking about lots of data here. And it opens up a few problems, including potentially small screens. We are talking about mobile devices, so tablets and phones, and potentially large data sets. And it only becomes a problem when you actually want to find something. You want to get to some data that isn't on your little screen. So when I've got a cell that's in the middle there, how do I get to it? What are the techniques that we can use? So traditional things, paging from 90s. I'm sure everyone has experienced a web page where you're having to click through a little arrow that takes you through views of the table that you're looking at. And then the advances came in the ability to kind of filter that data and search it. So you're filtering down the set of data that you want to interact with or look at. But these days, especially on a touchscreen device, we're more likely to try and scroll around and move with our fingers and try and interact with the data in a much more visceral way. So that's where we want to get to. So what is the Scrolly Grail? Well, I'm going to spoil my talk nice and early up front and tell you now that I'm sorry, there is no Scrolly Grail. I've been selling you a lie from the beginning. And that's because there are only compromises. There are always compromises. We're all developers. We've all had to go there. We've all had to look at problems and work out, okay, what's the least worst way of doing this? But you can prioritize and you can work out, what is your Scrolly Grail? What are the things that matter to you? Where can you compromise? And so for me, in this talk and the examples I'm going to give, there are three things that I really care about. That is smooth scrolling on both iOS and Android. And I'll come back to the differences that we care about, even though we're building one component in React, in JavaScript for both. The ability to fix a column in place. So a column on one side of my grid is going to stay fixed to one side, glued there so I can see, column headers, for example. Row headers. And fixing a row in place, so one or more rows at the top of my grid fixed in place so that I can see the column headers and have context for the information that I'm showing the user. I'm going to quickly run through a couple of core components in React Native that you might choose to try and use to build up something like this. So one of those is a scroll view. It's pretty much spelled out there. If the content's bigger than the scroll view, it lets you scroll. Magic, great. Sounds like it does exactly what you want, but there are some limitations on it. You can only scroll in one direction at a time. So I can only have a scroll view that scrolls in the x-axis or the y-axis. And it renders all of the information that's passed to it at once, which is a problem when you've got, let's say, a grid with 10,000 rows. If I only care about the first 50 being on screen at any one time or less, that's a lot of wasted cycles rendering a lot of stuff off screen. I'm probably going to get some memory issues on an old iPhone or an old Android device. The other component that's important for us to talk about is a flat list. Now, this is very closely related to a scroll view. And in fact, it extends a scroll view, but it gives us a few more nice bits of functionality. So it still only scrolls in one direction at a time, but it gives us lots of convenient functions, and it also does a lot of virtualization for us because it's rendering a list of items rather than trying to render everything at once. It can go, okay, well, we've only got 13 items on screen, so I'm not going to bother rendering those 13 items. And as someone scrolls more stuff into view, it can then do that virtualization for us. Great. We want to take as much advantage of these components as possible because they've been optimized to work with the native components that are going to be rendered under the hood. I won't go too much into that for now. So what does a basic scrolling grid look like? There's not a huge amount here. It looks a lot like the earlier piece of code, but that diagram that you can see that is describing how the components fit together is quite key here. We've got a scroll view wrapping everything, which is kind of effectively our grid, and that allows us to scroll in the x-axis. That's letting us go left and right horizontally. And then we've got a flat list, which is going to render each of the rows, and that's what lets us scroll in the y-axis. That's letting us scroll vertically up and down. And the rest of it is exactly like my earlier static example. And this, it works pretty well. We can scroll up and down, and we can scroll left to right, and we've got our data. But Oh, and we get some nice things for free out of these components. So we get momentum and we get bounce, which, these nice extras, they can mean a lot to people who are, especially if you're looking at a big data grid on a mobile device. You can imagine being able to fling and watch it scroll down a bit further is actually really useful. But it still only works in one direction at a time. And we don't have that fixed header and fixed column. So, where are we at with our Scrolly Grail? Well, we've got nice smooth scrolling. Great. So one problem down, 2 to go. So let's talk about the fixed header. Well, actually, the flat list comes to the rescue here. We have a prop on the flat list, which is just sticky head indices and gives us the number of rows at the top to kind of stick to the top of the flat list. And that works great, as we can see in the GIF there. We've got our first row being stuck. Great. 2 problems down, 1 to go. I'm going to smash this talk. We'll all go to the pub early. So let's talk about fixed columns. And actually, this is where it gets a bit more difficult, because we can't just pin the first cell to the left-hand side, because we're, at the moment, if you think about this compositionally, we're inside a flat list. We're not rendering that cell inside our scroll view. And so fixing it to the end of the flat list, the scroll view that is letting us scroll horizontally, it's just going to scroll out of view. And so you'd have to then start taking the amount that you've scrolled in your scroll view into account, doing all sorts of offsets. And now you're doing all sorts of calculations and trying to re-render some animations. This isn't going to go well. We can already see that this isn't going to go well just through thinking it through. So let's take that first set of cells and put them in a separate flat list outside of our scroll view so that they can be fixed at the end. They're not even in our scroll view. They're not going to go anywhere. So they're nicely fixed to one side of the screen. And great. That works really nicely when I'm scrolling horizontally. But as soon as I start scrolling vertically, oops, I now have the problem where I've got 2 different flat lists which scroll independently of each other. So I have to try and, get them in sync. Now, we can start to do that in a fairly naive way by going, okay, well, if one scrolls and I have this little on-scroll callback that tells me I've scrolled the body, make sure that the column scrolls as well. And this is pretty naive for a few reasons, because we're only getting told that the scroll happens after it's happened. And you can see in this GIF, if you're eagle-eyed, that there's a little bit of a delay, especially on older Android phones, between the scrolling of the body and the scrolling of the column. On top of that, I'm having to put in a bit of logic to say, if I scroll the body, scroll the column, but don't try and make that feedback loop happen where I've just scrolled the column, now scroll the body, because you're going to end up with some really funny interactions that way. So I'm sticking logic and calculations into this render loop, which is happening after I've actually had a scrolling interaction. So this is not an ideal solution. Sorry, lots of Indiana Jones in here at the moment. So I'm going to talk about why that happens briefly. So for those who don't know, React Native works by having a JavaScript thread communicate with a bunch of native threads over something called the React Native Bridge. And there's Jeff Bridges there to help show me how that works. Now, if you imagine this bridge, you can send commands down it and you get information back up it. But those commands can't, they can't contain logic. They can't contain code like I just showed you, where I'm saying, if this scrolls, then make sure you scroll this one, but don't scroll me again if that one is the thing that didn't originate the scrolling. It's too complex for issuing. And if you think about it more like I'm sending a command. Think about it, I'm sending almost like a message, a JSON object or something like that down there. You start to get an idea of what the limitations are of that. So we don't want to have to send multiple things back. We don't want to send a command down, get some information back that we scrolled, and then send another command down to say, now scroll this other component. It's going to keep us out of sync. So how can we tell both of our flat lists to scroll at the same time? Well, this is where we come to a lovely idea of a pan responder. Now, a pan responder is something which takes a gesture from our device and gives us the information about that gesture while it's going on, as well as after it's finished. And this gives us a whole bunch of new things that we can play with here. But if I just bring in that pan responder to kind of wrap the entire thing, so I'm wrapping now my scroll view and both my flat lists in this pan responder, every time a gesture happens, I can then take that information and tell both the flat lists and my scroll view to scroll at the same time. So this is the added bonus of giving me that vertical and horizontal scrolling at the same time, so I can now scroll diagonally, which is a huge win in terms of user interactability. And it's allowing me to cover that problem of synchronizing my scroll lists, my flat lists. So we can see the code here that's doing that. This is really just showing you the pan responder being set up and some of the logic in there. So don't get too hung up on the code again, but you can see there, effectively, I've got that on pan responder move. I'm just saying, hey, give me that gesture, calculate the offsets, and then send that to all three of those scrolling. So my grid X, my grid Y, and the separate fixed column all at the same time, or as close as is at the same time that the bridge will actually pack those messages together and send them off together. And you know, that's great. That works really well, except it doesn't quite work that well. We can see here, and this only happens on Android, and for the life of me, I've never been able to work out why. We get this little jumping effect in the header at the top. You might be able to see it, again, if you're eagle-eyed, and certainly users interacting with a grid all day long are going to experience that. Android, it really can be the bane for doing React Native development. So in order to get around that, I actually do cheat a little bit, and we actually manually fix that first row rather than using the flat lists sticky indices that I showed you as the first bit of our solution. So manually fixing that to the top of the scroll view inside the flat list, or outside the flat list, over the top of the flat list or at the top of it. And I could do that for as many rows as I wanted, but in this example, we're just going to fix the first one. And that would overlay what's going on there. And we can see that actually when we do that, it works exactly the same as the previous example, but now we don't get that jump up and down. And we can see we've got nice smooth scrolling even on, I think in this case it's, I can't remember what emulator I used, Nexus 5, I think, for this one. But again, it's smooth scrolling, it's nice, it works really well on Android and iOS, and it's all in JavaScript. So great, we've achieved our Scrolly Grail, right? Not quite. There's still a few other bits and pieces. So we've lost some of the nice bits that we had from using the native scrolling behavior of flat lists and scroll views. We've lost the momentum that we had for free. So if I do a fling, I'm doing all the maths myself on that gesture to work out how far I'm going to scroll in any given direction. So I've lost that. I need to recalculate that myself, and then continue to tell the components to animate and to scroll in those directions. And I've also lost the bounce, which is natively there on iOS, and you lose that as well, which it's a minor thing, but still, it's a nice to have, you know, when you over scroll on something and it bounces over. And actually, talking about over scrolling, we have an extra problem here whereby if we're just naively calculating the amount that I'm scrolling in one direction, well, I can keep gesturing off the end of this grid, and therefore it's going to keep adding up that number. And so I'm going to massively overscroll off the end of my grid in one direction, and my user has to scroll back 50 screens to get back to the beginning, to the point where it's going to scroll back in the other direction. So we have to take all that into account, which is, you know, kind of rubbish. But all of those things are actually really possible, and I know because, well, we did them at Anaplan, and so you can see here the actual Anaplan app here with a nice grid which is now got nicely formatted cells with interesting content, but also it allows us to do, using this pattern, and I do call it a pattern, things like having this animated fixed column. So the column that we previously fixed on the left-hand side is now something that we can animate in and out while we're doing those gestures to give a bit more space for someone to see the data in their grid. Because again, we're working on these small devices. We want to maximize the amount of space. And just to show you that the Anaplan mobile app isn't just one giant spreadsheet with many, many dimensions, you can see some other screenshots there of us doing, you know, other things that you'd expect from business intelligence and kind of business modeling. And that's kind of where we're at the moment. We've made a lot of advances on top of that in terms of how we're using this. But as I say, I call it a pattern because I wouldn't necessarily take this and try and release it as a library or anything like that, because we're just putting together the existing components. And as I said, this is my Scrolly Grail. This is what I needed to prioritize. If you need to prioritize something different, say you're actually more interested in columns than rows, or you have different optimizations you need to make, then you might want to piece these together in a different format. But the fundamentals are still there of using that pan responder to overlay everything, and then if you need to fix something, taking it outside of the actual body of the grid and controlling those components separately, but keeping an eye on how you're sending those commands down that native bridge. I'm going to throw in an obligatory we're hiring slide, because when I started at Anaplan in London about 2 years ago, almost exactly 2 years ago, I think we were about 20 people in the London office. We're now 130 odd. And still growing. So if you're interested, please do come and give me a shout afterwards. There's a bunch of swag on the table over there. So give us a shout. The examples from this talk are all available on GitHub. If you have Expo on Android phone, you can actually try this out. I'll come back to this slide in a moment. But you can check out all of the code examples from this and compile the app yourself if you check out my GitHub there. And there's also a recording of this talk that I did previously at React Native event. So you can see going through all these slides again and the explanation if you want to. So I'll whiz back to that for anyone who wants to try that out in Expo on an Android phone. Sadly, it won't work on iOS. And say thank you very much for staying this late and for your time.